So it's been a minute since I've posted any updates on Crash. This is the infamous cheap yellow display. It's got an ESP32, RGB LED, SD card slot, bunch of ports, some pads you can solder to for hard connections, all the good shit that an ESP has, plus a touchscreen display. Now, I'm not using the touchscreen because I really don't have a need for it, but it does have a really cool serial port right there, and that is the same serial port that the environment uses on the serial monitor to program it. But I can also bring out a second UART on S3 and S5 there, so that's beneficial. I've even got a couple of pads over here that I can make use of if I want to. Focus! Yeah, 4 and 2 are over there. So there's that. The RGB LED is set up right now to change color depending on what the system is doing. But let's get to it. So this is the chat kernel I've been working on. This is going to interface directly with the Movi speech synthesizer board so that what it outputs will get said naturally. This doesn't use the internet. It's not ChatGPT. It's not an LLM. It's essentially a very glorified if statement if you really break it down. But it is a bit more than that. We're running free rtos, which is a real-time operating system for the ESP32. It takes advantage of the dual-core setup and allows us to pin different tasks to different cores. So the front end that you interface with runs on one core, while all the background tasks, the lookup, the conversational structures, etc., run on the second core in the background. So on the screen here, we just have the kernel's name, a little bit of system information. The storage space does update live. I don't have very much on the SD card at the moment, but I will before too long. Down here at the bottom, it shows the last couple of things that we've said to it and keeps track of that. On the SD card, we have a library that we're developing for the chat kernel, as well as a couple of other files specifically for holding memories and logging other events, as well as a file that logs the history of the chat between the unit and the whoever's talking to it. So this is just a bare bones system, a jumping off point, but it's taken me a good minute to figure out how I wanted to do this. It started off thinking I had some code from a video game that had been written to allow an NPC shopkeeper to interact with a player. And I started with that, and it's grown into this over the period of a few months now. So up here on the screen, see how well we can focus this out. We got everything broke down into the tabbed UI here. So we've got the kernel, the task UI, the database, and then my cheat sheet, which has all of my my cheater information broken down into different groups. So like how I put together sentences in order to teach it and forget things and command things through the system while talking to it. Different things I have to keep track of while doing the coding. Yeah, this is for writing things to the card. This is the actual stuff that makes it work in here, and then that's the front end, which is pretty small. Pin setups and assignments and all that good stuff. So let's get to the fun part here. So first thing you'll notice is I have no tripod. So this sucks, but we'll just type something simple like hello, and it'll respond. Now I can ask it, I can speak to it naturally. This is the cool thing that I've recently achieved. And while speaking to it naturally, it can pick the sentences apart to get to the point of what you're trying to ask it. And it knows to look out for certain words that are just junk words, and it picks those apart. We can teach it things through conversation that it will remember and add to its database, as well as it can scan its database to bring up information that it knows. So right now I can ask it something straight up like, how are you? And normally that structure would require multiple if statements to cover every version of how are you and how do you feel. And you can actually see in the middle of the screen here, it says who are you, how do you feel, and it's got the 2 lines there. But you'll notice that there is no tag there for how are you doing today. So I can also type in, yo, how you doing, kid? Right? And I can hit enter. And it doesn't know that because there's a bunch of words in there that it keys up on. But I can be like, how are you? Sorry. I can be like, how are you today? I really need a tripod. And I'll get a similar response. How are you feeling today? Right? And we get the same response. I can say, tell me about Arduino, or about an Arduino. There we go, return. And it gives me the definition for the word that it knows as it knows it. But I can phrase this pretty much however I want, like, yo, hey, what is an Arduino? And it gives me the same answer. And the cool thing is that the conversational matrix doesn't require dozens of these. There's a couple of these that are set up specifically so that those questions don't get lost in the filter. But that's not the bulk of the conversation. The bulk of the conversation actually goes through the filter. Let me see if I can remember where I got that at. I think that's actually in task database. Yeah, incoming query, action, forget, learn, lookup. Here we go. So this is the command. This checks all the records on the SD card in the files, and it looks through those for keywords in the sentence, and it drops the words that are in the request that's sent that don't matter, and then picks up the ones that connect to things in the database. Now, this probably makes no sense because you haven't seen the database. So let's pop the chip out. And we're gonna put it, it's just a little 8 gig SD card. We're gonna put it in the computer. And we'll look up the chip. Crash chat. And this is the database. So we have words broken down by alphabet, so A through Z, and then he's got his memories, right? So we'll open these and I'll show you. This is the chat log here in memories, what the operator asked about, and what was the response. Eventually these are going to get changed. It'll end up with timestamps. I haven't added the DS1307 clock to it yet. That's all right. But then if we go to the other letters, like here, Z, these are all the things he knows that start with Z. Z-axis, Zener, Zero, Zinc, Zif, Zbod, Zbit, Zblock. I didn't have a whole lot of Z words. It has whether they're a noun, an adjective, a verb, whatever, and then the explanation that we want. And we can type as much text here as we want, and it'll fill it out. And the cool thing is that it automatically parses all this text at the lookup, and it puts it out on the serial port in an appropriate speed and whatnot for the Movi soundboard to pick it up. So let's go to like S, right? And I got a bunch of words for S: sample, saturation, schematic, scope, sensor, serial, right? Let's go up to like D, Darlington, dashboard, data, right? You'll notice that it ends at diode here. Starts at Darlington, ends at diode. And Those are all the D words that it knows. So now we're going to close this. Oops, that's big. Go back. Close that. We're going to put the chip back in it. Now, you notice I didn't reboot it, right? So we're going to come back up to here. And we're going to go, hello. You still doing okay? Doesn't know that one. So we still have some work to do, but that's okay. Now let's ask it, tell me about cereal. And it goes right back to being able to read from the library. So the cool thing is, I can take the card out and I can update this card live or dynamically or however you want to list it without crashing the kernel. If we just pop it out and we ask the same question again, right? It doesn't know, but it's still running. And you can see on the screen, error, no matching terms found. So now we can pop the disk back in. And we will ask it one more time. Oh, I hit the button, it rebooted. Crap, I screwed up my little presentation. Oh well, you get the point. We already did it once when we pulled it out to look at the information on the chip. Anyway, it doesn't crash the kernel. I can take it out, I can put it back in, take it out, put it back in. And if I ask it, it works. Right? So now we can start building onto the conversational matrix with new information. And the neat thing is, he doesn't use Google. He doesn't use the Oxford Dictionary. He doesn't use anything. So the things that he will learn will be unique to him. As he interacts with more and more people, the conversation will develop because the definitions will develop. And as those change, depending on the interactions he has, he will change in how he interacts. So in a way, he'll grow, kind of from an infant state to a more advanced state. And there's a lot more features I want to add to this still. We still have to include serial protocols on the second UART that I added in order to interface it with the ESP32 that runs the body, so that we can trigger the actions in the hand movements and the head movements and everything like that in sync with the text. And that's coming up. But I had to have something working first that we could actually talk to comfortably. And I think we're about there. Yeah, I got some like graphical tweaks I got to change. That dropped down and it changed the text color for some reason. Just annoying little shit, but it's in the works. Anyway, that's the update. That's where we're at with this, and I think it's pretty cool.